All right, so periodic table and the periodic trends. So some of the learning targets is that you need to know that the periodic table has trends, okay, and those trends help us identify or help us see, we can predict what's going to happen with the next element because of these trends. The first periodic table was credited by Mendeleev, and these are things I'm going to go back over this. So it's organized into 7 periods and 18 groups. A period is the periodic table, indicates that the energy level. So if we have 7 energy levels, then we have 7 periods. If they are successful in making this new 119 element, then we'll go up to 8 periods. And then groups, okay, so periods are like this, and we have 7 of them. Groups are our vertical columns, and there's 18 of them, and those are based on the valence electrons. How many valence electrons are there? And they all happen to have similar chemical and physical properties. And I think I hit a slide that has that on there. So vocabulary, words you're going to hear me say, that should be alkali metals. These are basically our, These are basically our families that we're going to be looking at. And then some of the trends. I think this unit is a lot of memorization, just memorizing where the families are, what the families' characteristics are.
So this whole unit is over the periodic table?
It's all about the periodic table. And then the next unit, we're going to jump into making bonds. We're going to start bonding. So the very first periodic table was made by Dmitry Mendeleev. And he did exactly like you guys did last Friday. He had all those little properties, and he started putting them into an arrangement. And he noticed that there were patterns. So you need to know that Mendeleev put them in order of their atomic mass. And their chemical and physical properties. So he went increasing atomic mass, and then he would see that you would have soft and silvery, you would have white and malleable, and you would have all these properties, and then you'd have a gas. And then the properties started over again. Soft and silvery, malleable, all these other ones, gas, and then it started over again. And so that's why we say it's periodic. It's a pattern that keeps repeating itself, okay, at regular intervals. I think there was like 60-something of them. Okay, any questions on that? So this is kind of what it looked like. And you'll see that when he started doing this, he would have a blank spot. And he would say, oh, there's something there. He predicted that there was something that went there. And he would just leave it blank. And then, lo and behold, a couple years later, they discovered this element. And that element fit right where he said something would fit. And it fits the exact same properties that that family has. But there were still some unanswered questions. Some of the elements, if you look up there, and if you're going by atomic mass, some of the masses don't go, like cobalt and nickel, we go from 58.933 to 58.69. So it didn't fit perfectly. And so we wanted to know why. And what was the reason for that periodicity? What was the reason for that repeating pattern? So Moseley came along. You need to know that Moseley, he took the periodic table and he put it according to how we have it now, by the number of protons. So rather than doing it by the mass, he did it by the protons, and we still have it underneath that same physical and chemical properties. So Mendeleev was mass, and Moseley was atomic number. And those are the two scientists for this unit. Only two. Any questions? Are you mad at me? Okay. So the periodic law says that the physical and chemical properties of the elements are periodic functions of their atomic numbers. So because of their atomic numbers, we have this periodicity, we have this repeating pattern. Okay? We get to the end, and then we see that we have those properties repeating again. Get to the end, and then our properties repeat again. So this would say be silvery metal. And this would be a gas. I think the next slide is where we're going to color it. I'm going to kind of go over where everything's at, because it's kind of hard to see unless you have your iPad, and I'm going to give you guys about 10 minutes to color it. And if you don't finish in that time, then you'll just have to color it at home. Or maybe we'll finish coloring it tomorrow for our warm-up. Yes?
Are there any points in the periodic table to where they're ordered perfectly by the number of protons, but there's a point where one has a lesser number of protons but a greater mass than another?
Well, that would be like the cobalt nickel situation. Okay. So here is the periodic table. And I'll be writing these out. So the very first thing I need you to do is whatever you have colored for a non-metal. So Luke here has his non-metals colored as orange. You need to know that hydrogen is a non-metal. You can color it whatever color you want. It doesn't have to be my exact colors.
No, I know, but I'm saying that we color it.
Yes, yes. Okay, so our very first, that very first column is called the alkali metals. Those are the only ones. The group right next to it are called the alkaline earth. Huh? Oh, well, you have this.
Wait, so lithium and whatever.
This the fall.
Oh, so I colored the...
Yes. What?
Lithium and beryllium are the alkaline earth.
No, sorry, hold on. This whole, oops, let me change my color.
Oh, okay.
So from
This whole thing right here are the alkaline earth.
alkaline?
Alkaline. We'll just scratch that out and put alkaline. Is everybody good with that? They're different. The next one, if this big block rectangle are called the transition. Transition metals. These purple ones right over here, that there's a little insert. So these purple ones right here, this whole thing right here, on yours they're called rare earth.
Are those all one color?
They're two different colors, but you can call them all one. Rare earth. You can just call them one color, and out to the side we'll put the names out to the side. Yes.
Is the luteum and the rancid part of that group too? It's part of the transition. The two right there.
These two right here, these are part of these group,
So we're
the rare earth. So Lu and Lr are part of the rare earth. Okay, so this is where I need you to pay attention. So right here, let me get a different color. The very last column are the noble gases. The column right next to it are called the halogens.
That's noble gases.
So we have noble gases, and then we have halogens.
And with the ones, the two, like, those at the bottom, they're
Uh-huh. Right there, but don't use them. They're back there. There's some, you see in that red round bucket? Or pinkish, there's some pencil sharpeners in there. Okay. These, the C, N, O, P, S, and SE. C, N, O, P, S, and SE. Those are non-metals. And then you have the green ones here. These green ones are called other metals.
So that blue one that she up there, that one goes with the,
You have whiteout.
I think there's some on my desk.
I use some.
Uh-huh. And then these right here, they make a stair step. Those are your semi-metals, your metalloids. Yes.
That doesn't necessarily match the one up there.
What are you talking about?
The periodic table on your wall, like, the metalloids with phosphorus and sulfur are not
No. On this,
over here.
right here, I just have my stair step. My stair step on that periodic table are my metalloids.
Okay, but what about that green outline?
That green outline, those are my diatomic metals.
So those pink and purple ones at the bottom are both
They are. And we're going to further clarify those as one is called the lanthanide.
We get to use our periodic table on 10.
Yes. So here, the lanthanide, and then the one below it are called the actinides.
What is?
Oh, yeah.
Okay, so the periodic table is grouped into families. Like we're all family. We have, if you have a family, then that means you have similar characteristics, okay? And each family has a name. And they're going to react differently.
I'm sorry. Where does helium has that category?
It's with noble gases. So I need you to remember that there are 7 periods. And there are 18 groups or families. Groups and families will be used interchangeably. So everybody in this column have similar properties. Everybody here has similar properties. Here have similar properties, okay? So families are based on their similar properties. And then the periods are based on their energy levels. So very first one that we're going to take a look at is hydrogen. And you just need to know that hydrogen is out by itself. Hydrogen is a family all on its own. And it's diatomic, which means what? 2 atoms. When it occurs by itself, it will be written as H2. So I kind of say it's a twin. And those are those 7 that are up there too. Those are twins. They're diatomic. And it's a gas. So hydrogen, family of its own, it's diatomic, and it's a reactive gas. The Hindenburg, when was the Hindenburg? Was it early 1900s? When it blew up?
It was like the 30s.
18 or 19? 1930s.
Yeah, because it was a Nazi blood.
So the Hindenburg exploded because of the hydrogen. So that's kind of the only thing. Next, we're going to go to that piece of paper that I handed out to you, the one that looks like this. Oops, where'd it go? Like this.
Oh, is that a sneeze? Wait, so it's really reactive, like, that's why they have the hydrogen bomb?
Okay. The first group, the very first column, without hydrogen, is called the alkali metals. The alkali metals. It's in group 1A, which means how many valence electrons does it have? 1. Everything in this group is going to end, their valence shell is S1. But we're going to put an N there, just so that N stands for the period number. So everybody ends in S1. So you have 1 S1, 2 S1, 3 S1, 4 S1, all the way down. And N is the period number.
So it's in S1.
So is it going to gain or lose to reach an octet? Is it going to gain 7 or lose 1? It's going to lose 1. Octet means 8 electrons.
Oh. Wait, that's just an S1 period?
And that the N stands for period number. So if it loses 1, what's its charge going to be? Plus 1. What type of element are these? Metals, nonmetals, metalloids? Metals.
I'm confused. If it loses one, how's that work?
Because it loses an electron, which counteracts the proton, so without the electron, it's positive.
Lithium has how many how many? 3. 3. So it has 3 protons. And it has 3 electrons, right? So an overall charge of 0.
How is that?
Wait, so it's not an element? I'm so confused.
How's that?
Zero.
Overall charge. Protons and electrons, they cancel each other out.
Oh, okay, I got it. How's it?
So if I have 3 protons and I lost an electron, so what's my overall charge going to be?
Positive, negative.
3.
This one. Oh, positive.
3 plus 2 minus gives me a plus 1.
Okay, got it.
Reactivity. These are very reactive, especially with water. Very reactive, especially with water. We have to store these in oil. So we store them in oil because if it gets any water near it, it's explosive.
Really? Can we do that? Like, see it?
Like how explosive?
I'll have to look and see if I have any.
Like dynamite explosive?
I mean, it depends. As I get further down the periodic table, the explosion goes more. All right. I have some additional information down here I want you to put. These are soft and silvery. So they're soft and silvery. Soft, I can take this piece of sodium metal and I can cut it with a butter knife. That's how soft it is. And they conduct electricity.
Are they used on the chest?
Yes. Except for Ruffin.
Well, you are.
Yes, Caroline.
Can you explain the EC comparison?
The outer shell, the electron configuration, what does it end in? So they all end in S1.
Okay.
And then I put the end, so that's the period number. So hydrogen ends in 1s1, lithium would end in 2s1, sodium with 3s1. Huh?
I was saying the end's just a variable.
Yeah, and yeah. All right, group 2. What's the next column on the periodic table? What's the name of it?
Alkali earth.
Alkaline earth metals. Alkaline earth.
What's the difference between alkali and alkaline?
An N and an E. I don't know. These are going to be just, they just gave them, I don't know, another, I don't know.
It doesn't matter.
Some call it alkali earth. So, these all have, they're in group 2A, so how many valence electrons, Luke, do they have?
3.
Try again.
4. 2. Oh, that's close.
We were not.
You were going the wrong way.
It was pretty close. First guess is 1 off.
They all end in N, which is the period, S2.
Like, so it's just one of these, like all the other groups are just gonna be S3, S4, and S5.
No, because you can only have 2 in your S.
Okay, so what would the end change to?
For the other ones, it's not going to be S. Well, it comes after S block. Okay,
No, but I'm saying end.
N, it's your period number.
It'd be N, T.
Is it N2?
and S squared, and S2. Okay. These are all going to do what, Luke?
Lose 1.
Lose 1?
2. Lose 2. 2, okay.
To get what type of charge, Luke?
Positive.
Positive what? It's not positive 1.
Positive 2.
Positive 2. Wow, are we starting to see a pattern here? Oh my gosh.
I'm just waiting for the,
I see a pattern. It's pick on Luke day.
What type of element is it?
Metals.
And these are reactive. So reactivity is just high. It's high, not as high as the alkali earth. Alkali, sorry. Extra information. What?
They like use like alkaline metals in the exposure.
yeah,
Batteries.
yeah.
Oh yeah, because there's like chemical reactions.
I ate a battery. Am I screwed?
Alkaline earth metals. Additional information. These are white and malleable. What does malleable mean? You can hit it with a hammer.
White and malleable.
And these also
See if Richard's malleable.
conduct
Never mind.
electricity.
Don't worry about it.
How do you spell malleable? Is that an EA?
Malleable.
Yeah, it's probably, yeah. Didn't spell it right.
I know they said it.
Oh.
Oh, by the way, Alvin, we do get the easy one.
Except for roughing.
Yeah, I'm like,
We only have 6 minutes.
Okay. I can get a lot done in 6 minutes.
I know, I'm just saying.
I'm glad when you have fun.
Homework.
we don't have any this unit.
Except for roughing.
What on earth?
Uh,
I don't know what it is with me and Luke, but we're just targets today. I feel singled out.
Just today, though.
but it, so come tomorrow with this. We're going to fill the rest of it out. And then,
Does it just go on like that? Like
What slide is it in?
valence, like group 3 will be transitions, and then valence is
How did you
3.
get to it?
what's weird is these groups here, they're not going to be part of the transitions. We're going to kind of change their names.
Oh, so we
But-
don't do any of this?
No, don't do anything. All right. No homework for this unit.